Algebra lesson 3-3. We've spent some time now dealing with one-step equations, solving equations with addition, subtraction, multiplication, and division, and how we use inverse operations to undo the process with our goal of eventually getting the variable alone, or isolating the variable. So it's a little game. We play this game and we move stuff from one side to the other until eventually we've accomplished that goal of getting the variable all by itself. So remember, there's always something that you can do. You can, as long as you do it from one to the other side as well, you must do it equally, fair, whatever you want to refer to it as, so that it's the same on both sides of the equation. Now, we're going to take it a step further, literally, and instead of dealing with one-step equations, now we'll deal with two-step equations. And there's a lot of different ways we could go about this, but I'm going to try to give you some examples here that might help you out. So our first one. We've got 1/2 being multiplied by an unknown number, x, minus 5, then equals 10. Now remember, I've once demonstrated before that here we are in a number, and we multiply it by 1/2, so that's like a step. And that gives us a new value. That value then is subtracted by 5 to result in 10. I need to undo everything to make it back to the original number. So one thing I ask people, and obviously on this one I'm going to change this subtraction to plus the opposite. Again, that's not a mandatory step, but I do feel like people are, more likely to be successful and have fewer mistakes if they make that step. But one thing I tell people is, what's the normal? If you just were normal order of operations, if that wasn't an x, if it was like an 8 or a 20 or something like that, what would the normal order of operations be for something like 1/2 times 20 plus negative 5? Well, normal order of operations would say you've got to take care of the multiplication before the addition. Okay, so in this particular problem, the normal order is to multiply right here by 1/2. So we'll say times by 1/2. And then after that, after you've multiplied by 1/2, the next step would be to add negative 5. So that's the normal order, going like this. All right? Or if you'd rather, step 1 and step 2. Now, in order to use inverse operations, we've got to reverse the order and do the opposite. So if we reverse the order, this is no longer going to be first, that's going to be first. And I've got to do the opposite. What's the opposite of adding negative 5? Adding positive 5. So I will add positive 5. But remember, what you do to one side of the equal sign, you must do to the other side of the equal sign. Now we multiply. Those cancel out. I'm still left with a 1/2 x is equal to 15. Okay, I just took care of that. I just did the opposite of adding negative 5, and I added positive 5. Next on the list, I've got to take care of this times by 1/2. Well, the opposite of times by 1/2 is to divide by 1/2. But we know that instead of dividing by a fraction, you can multiply by its reciprocal. So I'm going to multiply this by the reciprocal of 1/2, which is 2/1, and hopefully you notice that everything's going to cancel out. I must, whatever I do to one side, do to the other. So if you want, you can make that a fraction as well. Now you'll see that the 2's cancel, the 1's cancel, x is alone. I've isolated the variable, and 15 times 2 is 30. Just took care of that step. Now if this is done correctly, I should be able to take this answer, plug it right back in for x, and it should work. Let's see. 1/2 of 30 is 15. 15 plus negative 5 equals 10. So it works. So that's one method that you could use. One method. All right, another example. A little bigger now. It's got more going on. That's okay. 2x minus 9x plus 17 equals negative 4. Now before you get carried away, hopefully somebody's recognized we have a subtraction sign here. We can change that to plus the opposite. And before we start playing the shuffling game, before we start moving stuff from one side to the other, we always want to look and see if there's anything that we can simplify. And right here, these have the same parts. So we add them together, because you can add like parts. And I have 7 more negatives than I do positives. So I have negative 7x plus 17 is equal to negative 4. Okay, Now, the normal order of operations would be multiplication followed by addition. So normal order would be to multiply by negative 7 followed by add 17. That's the normal order. 1, step 2. I've got to reverse the order and do the opposite. So if this is step 1 and this is step 2, I've got to go the opposite way. The opposite of adding 17 is to subtract 17, or to add negative 17. So if I add negative 17, this positive 17 and that negative 17 cancel each other out. What you do one side, you must do to the other. What's really nice about adding negative 17 instead of subtracting positive is that here's a negative, so it works out well. Those cancel out. Negative 7x now equals negative 21. Negatives plus negatives makes more negatives. So I go back up here, I just took care of the plus 17. Now I got to take care of this multiplying by negative 7. The opposite of multiplying by negative 7 is to divide by negative 7. Watch out right here. A really common mistake is people put a positive 7 because they think it's opposite. You don't want it to be opposite, you want it to be exactly the same. When it's addition or subtraction is when you want it to be opposite, but not for division and multiplication. What you do to one side, you must do to the other. The negative 7's cancel. X is now alone, isolated the way we want it. Negative divided by negative makes a positive, and 7 goes into 21 3 times. Just took care of this. Now if I want to test it, I should be able to plug that number of 3 back in. 2 times 3 is 6. Negative 9 times 3 is negative 27. 6 plus 17 is 23. Negative 27 plus a positive 23 that would be here is 4 more negatives. It does work. Okay, taking it a step further now. We're getting a little bit harder each time. You'll notice that there is an x inside the parentheses and there's a 4x out here, but we can't add these yet. The reason we can't add them is because of the parentheses. We must take care of the parentheses first. And I wouldn't be afraid to go plus, negative, and maybe put a 1 in front of that x. It's not the end of the world. Now we take the number 12, and we're going to distribute it to both the parts inside the parentheses. We now have 4x plus 12x plus negative 36 is equal to 28. And if you notice, this problem right now looks awfully similar to this problem right here. Stuff with x's, stuff with x's, stuff without equals stuff without. Stuff with x's plus stuff with x's plus stuff without equals stuff without. It's exactly the same kind of problem now. It just was one more step with the distributive property. So we take our like parts, we add those together, we get 16x plus negative 36 is equal to 28. Now, excuse me, let me see now if we can do this without making the list of what normal order of operations would be. If you look at this problem, this stuff has x's, this stuff does not have x's, this stuff does not have x's. You want to get the stuff with x's on one side and the stuff without x's to another side. It doesn't matter which side, just separate them. Alright? Think about, this is all the people with blonde hair, this is all the people with brown hair. You want to get everybody that's the same on one side. So here I have a negative 36, and I want to get it over there because it doesn't have x's, and neither does the 28. So I will add 36. And those cancel out, leaving me with 16x is equal to, now I need to add these, because they're both positive, 64. Okay, I'm left with one final step. My objective is to get x completely alone. This is multiplication, so the opposite of multiplication is to divide. What you do to one side, you must do to the other. 16 goes into itself once. X is alone. 16 goes into 64 4 times. So our final answer is x equals 4. We've isolated. Again, inverse operations, separating the stuff with x's from the stuff without x's. Another one. Now this one has some real problems. People are pretty good about changing that to plus negative 9 and putting a 1 in front of that. But what a lot of people forget is there's a subtraction sign right here. And I really, really suggest that you make this plus negative 5. If you don't, let's just say you don't do that. Very common mistake is people write 2x minus 5x minus plus negative 45. because they distribute here, which is good. You do want to distribute. But if you're not careful with your signs, things can be wrong. So just be very, very cautious about that. All right? If you make this plus negative, then you know you're going to take care of your signs correctly. 2x plus negative 5x plus a positive 45. It's very possible that if you didn't change this, someone might write negative 45 here. Just be careful about that. Equals 27. Now again, stuff with x's, stuff with x's. Stuff without x's, stuff without x's. The stuff with x's needs to go together. So you add these together, you have 3 more negatives than you do positives. And we're in a situation where we have stuff with x's and stuff without. Get the stuff without x's to the same side. Get everything onto one side. So I'll add negative 45. And when I add negative 45 to both sides, I get negative 3x equals, I'm looking at this and I'm thinking to myself, how many more negatives are there than positives? The answer is negative 18. Last step, I need to get x completely alone. In order to get x alone, I got to do the opposite of multiplying by negative 3. So I divide by negative 3. Again, I want these to be the same sign so they'll cancel out exactly. I come over here and I divide by negative 3. Those cancel out, and x equals 6. You can always plug your answer back in and see if it'll work. Negative 3 times 6 is negative 18. Negative 18 plus 45 is 27. You can put it up here and it'll work. You can plug it in up here and it'll work. Anywhere in here, x of 6 will work. And one more, a little trickier. This says 12 equals 3 over 10 times the parentheses x plus 2. Now this is harder. One of the things that's tough about it is it has this fraction in it. So I'm going to give you a little tip. Here's how you can get rid of that fraction. Multiply by its reciprocal. But whatever you do to one side, you must do to the other. So over here, I'm going to multiply by the reciprocal of that fraction. I know that seems strange, but I've now completely gotten rid of that crazy fraction. And over here, 3 goes into itself and into 12 4 times. So 10 times 4 makes 40. And I have 40 equals, all that's left on the other side is x plus 2. Now it's a really easy one-step equation because I multiplied by the reciprocal to get rid of that fraction. Add negative 2, add negative 2, and I end up with 38 is equal to x. You want to test it out? You can. If you put 38 in here, 38 plus 2 is 40. 40 times 3 would be 120. Divided by 10 is 12. So it works in the original problem. Multiplying a fraction by its reciprocal will always cancel it out. Just make sure whatever you do to one side, you also do to the other, to be fair. All right? Looking back at this problem, you had a fraction in it. If I were to give you another example of that, 1/2 x minus 5 equals 10. 1/2 x minus 5 equals 10. You can change that to plus negative 5. And then one thing I think about is multiplying everything by 2 over 1. You multiply everything by 2 over 1, like a distributive property. This 2 over 1 times that 1/2 over 2 will cancel them out, leaving you with just x. This 2 over 1 times that negative 5 will make negative 10. This 2 over 1 times that 10 will make 20. And now you have no fraction to deal with, and all you have to do is add 10 to both sides, and you end up with x equals 30. So that's another little trick you could use. If you recall, we had x equals 30 when we did it the other way as well. If you're not comfortable with this method, but you get the other one, that can work. Just a way of getting rid of the fraction. Not everybody enjoys working with fractions in the problem. Remember, inverse operations, do the best you can.